Hello and welcome to today's webinar in partnership with Constantia Flexibles, hosted by Packaging Europe. Today we'll learn more about the power of aluminium in flexible packaging from Constantia Flexibles and their partners. So my name is Elisabeth Skora. I'm one of the editors at Packaging Europe. So for those of you who are unfamiliar with Packaging Europe, we are the leading intelligence resource for European packaging professionals via magazine and website, as well as online and in-person events such as the Sustainability Awards and Sustainable Packaging Summit. We deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players, and enable communication across the packaging value chain. So for today's webinar, we are joined by Stefan Lampe, who is Vice President Product Management at Constantia Flexibles. Also Sergio Buttiglioni, who is Head of Business Development at AMAG Austria Metall. And also Andreas Reisner, who is Managing Director at PreZero. In this webinar, our speakers will explain how aluminium works in a circular economy, showing all the steps along the way from sourcing the material to converting it into flexible packaging products, and the special technologies behind recycling aluminium using the newest technologies. We'll also take a closer look at aluminium in packaging and hear about AMAG's low-carbon aluminium Alforever. After that, Constantia Flexibles will discuss how converting the raw material into packaging products can be done sustainably, and they'll talk us through the different products available and how they contribute to saving materials and boosting recyclability. PreZero will then present their LIBS technology and how they pre-treat aluminium and also their pyrolysis technology. Before we get into the webinar itself, just a little bit of housekeeping. There are 15 minutes at the end of this webinar reserved for Q&A. Using the chat facility, please direct message us with any questions you might have, and we'll put them to us presenters at the end of the session. You can do this throughout the entire webinar, and we'll try to get as many of your questions answered as possible. For any technical questions, please select the support button, which you'll see on the left-hand side of the screen. And for streaming-related issues, you can also use the help button on the bottom of the right-hand stream window. With that, let's take a quick look at who Constantia Flexible actually is. So the company was founded on the guiding principles of people, passion, packaging, and manufactures, as we mentioned before, tailor-made flexible packaging solutions. Company has around 8,750 employees and is the second biggest producer in Europe and number 3 globally. And it also has a worldwide presence with 38 production sites in 16 countries. And its headquarters are in the heart of Europe in Austria's capital, Vienna. And yes, Europe's also the company's biggest market, followed by the Americas, Asia Pacific, and the Middle East and Africa. It serves the consumer sector, which makes up the major share of its business at 75%, and also the pharmaceutical sector, which makes up 25%. And yes, also obviously, we're talking about aluminium today, and that's company's got big expertise in that, with 54% of its output being based on aluminium, and 44% of production share is made up of flexible plastics. And you will be able to hear more about this in another webinar with Constantia Flexibles and Packaging Europe in early 2023. So yeah, make sure you check our website with updates on this. And last but not least, the company also works in paper-based packaging. This is currently only at 2%, but growing steadily. So yes, with after this introduction, it's now time to hand over to you, Stefan, to give us an introduction on the benefits of aluminium packaging.
Thank you very much, Elizabeth. Thank you very much for the introduction. And good afternoon, ladies and gentlemen. I'd like to welcome you all to today's aluminum webinar. Before we start with the presentation, let me briefly introduce myself. My name is Stefan Lampe. I have been with Constantia for about 17 years, working in different positions. And since about 5 years, I'm the head of product management, leading and technical applications. So why is aluminum such a fascinating material? And why is it being used in many different industries? And why do we believe at Constantia Flexibles that aluminum is essential to be used for packaging materials in the context of sustainability? Well, let's find out in the presentation later on. Let's start with the first page. Elizabeth, let me ask you a question. What do you think, how much aluminum is needed to protect 1 liter of milk per month?
Oh, that is a tricky question. I guess it's maybe not as much as I might think, but then I'm not sure. I'm going to go for maybe 10 or 20 grams, something like that. Oh, you've got the options here. I'm going to say maybe, I don't know, maybe
Not that bad.
1.5.
Not that bad. Okay, I'll give you the answer. So it's actually just 1.5 grams that is needed to protect 1 liter of milk per month in a aseptic beverage carton. 1.5 grams. Well, that's nearly nothing in my opinion. That's very less material to protect our food, isn't it? And that equates about the weight of one cotton pad. So very, very less material. So let's talk about the characteristics of aluminum. Aluminum is a very versatile material. It's lightweight, flexible, and its barrier makes it perfectly suitable for different industries, such as packaging, automotive, construction, aviation. We all know that. Responsible sourcing is a key element of Constantia's sustainability strategy. Why? We'll find out later on in the presentation. Aluminum is not expensive because it's rare. In fact, it's the third most common element in Earth's crust. It's so valuable because it's hard to extract from the rock around it. The majority of greenhouse gas emissions occur not in the aluminum smelter, but rather in generating necessary electricity to produce virgin aluminum. Therefore, recycling of aluminum is a key element, and we must keep its value to reduce greenhouse gas emissions. And so recycling uses just 95% of energy. Let's sip of water. Let's talk about the benefits of aluminum. Because the barrier of aluminum is to oxygen, light, water vapor, you name it, is so good, it's an excellent material to be used for packaging. Aluminum can be recycled again and again, and that's why aluminum is so valuable for both the market and actually the environment. In fact, 75% of aluminum ever produced is still in use. It's amazing, in my opinion. Recycling of aluminum saves raw materials and energy and reduces the amount of landfill. Aluminum is widely collected, sorted with using very efficient eddy current technologies, and at the end recycled through pyrolysis. On the next slide, we will talk about AC at Constantia Flexibles. Well, the whole industry is accountable for responsible sourcing, and so is Constantia Flexibles. Therefore, we are proud to be a founding member of AC in 2009. And AC is actually part of Constantia Flexibles sustainability strategy. Constantia Teig in Austria is already performance standard and COC, chain of custody, standard certified. But what is AC? AC is a global non-profit standard setting and certification organization with the aim to bring together producers, users, stakeholders in the aluminum value chain. We are committed to maximize the contribution of aluminum to a sustainable society. The aim is to work together and foster responsible production, sourcing, and stewardship of aluminum.
Great, thank you very much, Stefan. So now it's time to hand over to Sergio Buttiglioni, who is Head of Business Development at AMAG Austria Metall, who is a supplier of Constantia Flexibles. And he'll tell us more about how sustainability is at the forefront when it comes to aluminium production and share details about the company's low-carbon aluminium L4ever. So yeah, over to you, Sergio.
Thank you very much, Elizabeth, and thank you, Stefan, for the introduction about aluminum. Good afternoon to everyone. With the next few slides, I'd like to walk you through who AMAG is today and our take and our view on the low carbon footprint product. So to start with, AMAG Group at a glance. AMAG is an integrated aluminum company, so we make flat roll products as well as cast products. Our headquarters is in Ranshofen in Upper Austria, right on the border with Germany, and is certainly the most modern aluminum rolling mill in Europe if one considers all the investments that have been done here at site, and not only at site, in the past 10 years. We have a stake also in an aluminum smelter in Canada, which is the largest one over there. And with our 20% stake in this smelter, we have access actually to a low carbon footprint primary for our products to be made. Last but not least, and you see a whole set of pictures under there. We have invested in a company with 2 locations to make finished parts, primarily to the aerospace industry, but not only. So from this standpoint, you can clearly say AMAG is an integrated aluminum, because we make our product from the very beginning, controlling it all the way down to delivering to our customers. The key markets we served, of course, packaging in its various forms for food as well as for pharmaceutical applications, and then other sectors such as aerospace, automotive industry, with a whole variety over there, and other specialties which is in our portfolio. In figures, AMAG's turnover in 2021 was slightly south of 1.3 billion, with a total employee number of 2.1 thousand headcounts. And moving on to what I have to say next, you can clearly say and hear from also what Stefan had in his introduction before, that we have a strong focus on sustainability, meaning it's the big picture in front of you. We have at the moment the largest photovoltaic installation in the country, and we are even in the process of expanding it. So for the time being, we have over 60,000 square meters, which is a lot. I mean, in soccer fields, this is something like 12 of them. So it's really a great production for our internal use. Of course, we need much more, but it's a good start anyway. On the sustainability, let's say certifications, ASI is in our DNA, meaning we are certified COC, chain of custody. We are ASI performance certified. Over the past 2 years, we have achieved certification gold and afterwards platinum as to EcoVadis. We have been awarded by the Vienna Stock Exchange for the transparency in our reporting overall, and we have scored very high in the sustainability ESG index. So if we take a look at how aluminum is made, and that would be on the next slide to be shown. If you take a look at the whole aluminum chain, it starts from the very beginning, so from digging out something from the ground and then delivering products to our customers. In all this chain, there are emissions to be counted. So even in the very at the very beginning, from when something is dug out of the ground, there is a certain CO2 emissions to be accounted for. Then we have our own production, which is displayed in blue, and then with particular focus on what we deliver to our customer at our customer gate. We think, and our vision has been that in the end we deliver a certain amount of CO2 at the customer gate. And in this perspective, we wanted to take a look at the ways of minimizing this impact so that our customers can have products with very low impact on the planet, because in the end, in our vision, what matters is how much we impact on the planet. And we are glad also to have seen and to be a supplier of Constantia, which is also very, very attentive to this matter. And if you have the chance to have a look on their website and material, you will clearly see that they pay a lot of attention and respect to how much to responsible sources, to how much CO2 they have as an intake, as well as how much they do impact on the planet in the end with their product. So all this has a meaningful result, which you will see moving on, and focusing on the product itself. I mentioned CO2 embedded in the product. Yes, so we have created a brand, which I hope you like. The brand name is Al4ever, which denotes products with the footprint which is less than 4 tons of CO2 per ton of aluminum. We set ourselves even a more ambitious target which is 2. So the Al4ever Star is a product family that can be produced with a CO2 footprint which is less than 2. Very important here to mention, we are talking about standard alloys. So AMAG delivers very many alloys. Standard alloys means that these are still normed alloys, meaning that we do not compromise on the chemical composition. So if Constantia is buying that chemical composition for that particular alloy, for that particular application, we are still not moving away from that. We are just looking at ways and at how to produce the product with a very low CO2 footprint. So, of course, Constantia would like to have this certified, as I say, on a piece of paper. So the product come with a certificate that testifies that that particular product has been delivered with that amount of CO2 in it. If you'd like to know more, there is a separate section on our website where you can have a look. At the very last, and I conclude with my presentation, the CO2 footprint is really at the core of the Al4ever certified. It is a cradle to gate approach. So we are mapping precisely all scopes within production. Scope 1, meaning fossil fuel emissions in-house. Scope 2, electricity, so how much clean the electricity is. And Scope 3, the metal input, how much we in-source. And we map all of these scopes to be able to issue the certificate, potentially on every alloy, subject to feasibilities, of course, and we are happy to be discussing this with you today, introducing the Al4ever and what we do for Constantia. Thank you very much.
Thanks very much for that, Sergio. Thank you for sharing your insights. Now it's time to welcome back Stefan, who will tell us more about Constantia Flexibles' work to make packaging solutions with aluminium that are even more sustainable. So yes, over to you, Stefan.
Thank you, Elizabeth. And Sergio, well done, great presentation. Well, let's talk about reduce and replace, a couple of specifications that we have been working on currently. Well, actually the past couple of years. We replaced, the first one is called Eco Alulam. We replaced an aluminum paper multi-specification with a mono aluminum specification. Several customers are using this new development, and the material performs well on existing packaging lines, and that is always very, very important. Due to its monostructure, the material can be easily collected, sorted, and recycled. And of course, AZ aluminum can be offered to our customers. Well, the second specification, it's called Comfolit. Can we change the slide? Thank you so much. Comfolit, a very popular, actually my favorite specification. So our customers can easily replace the snap-on lid with a Comfolit and save about 20% of plastics. That's amazing. This specification improves the recyclability since the lid can be separated from the cup and disposed in separate recycling bins, alu to alu and plastics to plastics. The third specification, it's called Eco Peel Cover and Eco Multi Cover. It's either aluminum coax or aluminum heat selector. It's a standard die-cut lid, but not that standard because we reduced the specification as thin as possible, as thick as necessary. We reduced the sealant layers as much as we can, and the coax, for instance, from 24 grams to 13 grams, and the heat selector layer from 5 to 4 grams, and it still performs well at our customers. We proved that. On the next slide, we will talk about the retortable Eco Alutainer. Well, this is a very interesting specification. It's easy to sort easy to recycle, as the lid and the container are made of the same specification, the same material, aluminum. And the label is printed on the lid, on the bottom of the container and not sticked with a label on the container. We reduce the aluminum thickness without compromising the wall structure. So for this specification, AZ aluminum is already being used.
Well, thank you very much for that, Stefan. So now I'd like to welcome Andreas Reisner, who will share some insights into aluminium recycling and the company's LIBS technology, and also about aluminium pretreatment and pyrolysis technology. So yeah, over to you, Andreas.
Yes, thank you very much, Elizabeth. Thank you, Stefan, for letting us present here today. Briefly talk about PreZero Pyro. We are a company located close to Dresden, but in the city of Freiburg. We recycle around 80,000 tons per year there. Brief overview to the history of us. We were founded in 2005. In 2006, we took into operation our first pyrolysis, the pyrolysis on a basis of a drum. In 2011, we developed a second type of pyrolysis based on a decoding system. So currently we have two pyrolysis operating. All this material that gets thermally treated needs to either be pre-treated or after-treated, and therefore we took into operation a second state-of-the-art facility in 2013 to always continue giving a high quality aluminum granule to our clients. We had to develop different technologies, whether it was X-ray to get rid of heavy metals such as copper and brass, to also a laser technology to sort the different alloys into each group so that we can bring packaging material back into packaging material. In 2020, we started the new joint venture, which we currently are formatted with today, PreZero Pyro, and have around 90 employees. And as I said, we do around 80,000 tons of input material. Important, what we believe is very important for the future is the recycling targets of Europe, especially for aluminum light packaging. We believe the key technology is pyrolysis because it does not mechanically, it's not abrasive to the material, and we can recover all aluminum that goes into the pyrolysis. We can recover in the output, and therefore we believe that technology is very key into helping Europe achieve its target of 60% by 2030. Currently, just as a FYI, currently the rate is at 47% European wide. What is the pyrolysis? Pyrolysis is different from smelting. We take heterogeneous contaminated waste materials that have plastic, food rest, or paper contamination. We operate at 500 degrees Celsius without oxygen, which therefore allows us to recover all of the aluminum material that is in the input. Just so that some people see what kind of inputs we do, we have here a brief overview of pictures, because pictures speak 1,000 words. Here left, we see aluminum packaging material. We are the largest recycler of aluminum light packaging in Germany. We do around 60% of the market, so around 45,000 tons a year. We do bottle caps from glass recycling, empty aerosol cans, not full, beverage cans, coffee capsules with coffee with coffee remainings, aluminum foil trays, tubes, and aluminum foils. Our aluminum content is anywhere as low as 20% aluminum up until 90% aluminum. And as you see from the pictures, the output is always clearly non-touched. It comes out as we throw it in. Our future pyrolysis, the current pyrolysis that we operate, we produce steam and electricity. What we plan to take into operation next year is a catalytical processing of our synthetic gas. so that we take our synthetic gas and make a synthetic natural gas and electricity, which we will then be able to operate a smelter without any CO2, without any fossil fuel. For example, natural gas. We will be able to produce it using the plastics or food contamination that is in the packaging material that we receive. After the pyrolysis, we have a mixed alloy aluminum, a clean mixed aluminium granulate. These aluminium granulates have different herkunft, so they come from different areas. And here I just show a brief overview of how our laser technology works. It's like a fingerprint. We did many tests of different aluminum scraps, and here we just have two examples of two alloys, 5000 and 6000 alloy, and what we see is the different light densities, and each material that goes over the laser gets an electrical spark, and the spark then allows for us to identify its fingerprint, and the fingerprint then is associated into the alloy groups. What this allows us is to complete a cycle from completely heterogeneous and dirty scrap into clean alloy ingots that we can then sell to other smelters who make new packaging products, for example, AMAC or others. I would like to just briefly go explain the cycle of how packaging works. Packaging is usually started with a licensing fee. This licensing fee can go over a company like PreZero Dual. In the next slide. And after the brand owner brings the packaging onto the market, they have to pay a licensing fee. This license, the product goes onto the market. The consumer uses consumes or purchases the product. For example, a aerosol can. This aerosol can then gets collected through a logistical system and brought to sorting plants all over Germany. There are around 30 sorting plants in Germany. These modern sorting plants sort the yellow bin or all types of packaging material into different fractions. One of these fractions is called a aluminum light packaging fraction. And this aluminum light packaging fraction is the fraction that we then receive to Freiberg. The aluminum content has around 30 to 35% aluminum, and 70 to 65% is then plastics or food. And here we see on the picture how the clean aluminum granulate comes out. Again, the granulate is still in a mixed alloy. This goes over laser technology, which then produces a clean aluminum granulate with a specific alloy, which we then can sell, remelt into an ingot. And this ingot we can sell to companies like Neumann Aluminium that can make new slugs. And currently, we make these slugs out of 60% real PCR. So from used aluminum scrap, the new slug has a content of 60% of our granulate. These slugs then get sold to a company like Tubex that can make new aerosol cans and get sold to further brand owners like Lidl, which then lands back into the store for the consumers to buy the new product. And after the consumption, the whole cycle starts again, where it gets collected, sorted, and recycled. I hope this was a quick and brief overview. What we want to also display is that this is not just a prototype. We have been working on this partnership for over 3 years. Currently, we have sold over 100 million cans with our real PCR content in the can. Have won numerous awards, and look forward to creating more closed loop projects. It doesn't need to be aerosol can to aerosol can. What we want is that packaging material lands in packaging material. That is our goal for the future. And yes, that is our input to help sustain the aluminum light packaging, that it stays in this in a cycle and does not get lost into landfills or incineration plants. Thank you. If there's any questions, I guess Q&A comes later.
Great, thank you very much, Andreas. It was great to get an insight into this recycling technology. So yeah, now I'd like to welcome back Stefan, who will be able to share some more interesting facts about aluminium and sustainability with us. So yes, welcome back, Stefan.
Thank you. Well done, Andreas. Well done. Well, let's talk about a more sustainable future at Constantia Flexibles in the context of aluminum. Next slide, please. Key facts. So we are very well aware that aluminum is responsible for about 2% of the global greenhouse gas emissions. By reducing material specifications and recycling of aluminum, we can even decrease this figure. We understand the demand of aluminum will increase by 80% within the next decades. Therefore, the entire industry has to initiate the change and produce aluminum more efficiently by using renewable resources and recycle more aluminum. Aluminum is recyclable, we all know that by now, without losing its quality. The recyclability rate can be improved by using proper techniques, such as pyrolysis, what we just heard. However, we have to assure that different alloys will be separated by their main types, and sorting systems have to be implemented by the environment service providers that are engaged in waste and recycling. Well, that is actually a very interesting slide, as it shows on the left side an overview of the CO2 emission for the production of virgin aluminum versus the CO2 emission on the right side for the production of recycled aluminum of 1 ton. Not just the efficient usage of energy as well as the usage of renewable resources is important, but rather the need to recycle more aluminum is key. However, we are pretty much aware that we cannot cover the entire market demand with recycled aluminum. Very unfortunate. Well, this is the last slide and my favorite one because it shows the Constantia sustainability roadmap, which contains about 3 pillars: reduce, recycle, replace. Let's start short term. On the left side, down-gauging and replacing. We down-gauge specifications to efficiently use materials, following the slogan, as thin as possible, as thick as necessary. Well, on the bottom, we see replace. We also replace specifications from multi to mono materials, such as eco-alloy specifications, to ensure materials can be collected, sorted, and recycled. Recycle and reduce. We continuously increase recycled content in our specification. A very effective way to reduce carbon footprint is to maximize the usage of recycled content. Low carbon aluminum. Also, step by step, we will increase the usage of low carbon aluminum. Electrolysis has the highest impact of energy being used to produce virgin aluminum. Therefore, renewable energy in smelting, as well as increasing the content of recycled aluminum, is key. And also a long-term vision, what we have is to look into technologies. Actually, we do it now, but hopefully in the future we will have that, as wear and tear of standard carbon anodes is quite high in the process of electrolysis. Several companies are researching for different anode materials to extend the lifespan and to reduce CO2 emissions. Thank you very much.
Yes, thank you very much, Stefan, and also Sergio and Andreas for some really interesting presentations and some great insights. So now it's time to answer the audience questions and move on to the Q&A section of our session. We have a very engaged audience today, so we've already had lots of questions in, but obviously keep them coming. Don't worry if we don't get to your question. The speakers will be available afterwards to obviously answer your questions. So just get in touch with them via the email address that you can see on the screen right now. So yes, without any further ado, let's go to the questions. One question we had was, you mentioned one of the main benefits of aluminium being recyclable and thus a valuable material for the circular economy. However, paper and plastics are recyclable as well. And where is the main difference between aluminium and all these other materials? Maybe one for
Well,
you, Stefan.
oh, that is to me. That was about to ask. So this question is for me. Well, in the context of sustainability, it's fairly easy to answer. Aluminum can be recycled without losing its quality. This is what we pretty much learned in this webinar. If you use the right techniques such as pyrolysis and LIFs, what Andreas explained earlier. Well, yeah, that's pretty much a main difference.
Thank you very much. Another question we had was, in recent years, we've seen a very unstable aluminium market, including supply shortages. Can you comment on this?
To me?
Yes, if you
Okay.
have to
Yeah,
answer it,
absolutely.
yes.
Thank you, Elizabeth. Well, yeah, the market was unstable, but we recently received the last protocol from the AFA, and we've learned that in the second year of 2022, the aluminum market got a little bit stabilized. Well, of course, we have to take our learnings out of it, as it was quite difficult to get materials, but not just aluminum, all the other materials as well, and of course, pricing got increased. But well, what Constantia is doing, we're pretty much focused on alternative material suppliers, and not just for aluminum, but of course also for aluminum.
Thank you very much, Stefan. We had another one, which is probably for you, which is, how will foil be used in a circular economy?
Is it to Sergio, I guess?
Oh yes, Sergio can answer this as well. Yeah, that'd be fine.
I beg your pardon. What was the question?
How will foil be used in a circular economy?
Foil.
Well, aluminum foil, yeah.
Yes.
Well, not sure I captured the intention of the question, but let's say foil can be done can be reused as well in the circular economy. I mean, the foil could be used in for food applications, of course, could be used for pharmaceutical applications. It could be used for anything that requires flexibility and preservation of food. I think we all know by now that aluminum can be recycled and has been recycled for a very long time. So since the beginning, it's probably just a matter of and I stress the word just matter of organizing a proper collection then comes back to either companies such as Peral or the scrap circuit that also AMAC has access to.
Thank you, Sergio. And somebody else is asking, what about the cost and the state of the art of aluminium contained in flexible packaging for things like sachets? Maybe that's one for you, Stefan?
Well, obviously, I cannot speak about costs. I cannot do that. But yeah, I think the question is towards the virgin aluminum and the recycled aluminum. So there is a huge difference between using virgin aluminum and also recycled aluminum in terms of cost and of course in terms of CO2 emissions.
Thank you, Stefan. Somebody else was asking, can aluminium already laminated on paper be recycled? And if yes, does Constantia Flexibles have any plans to partner with local recyclers to build the capacity to recycle such products? Maybe that's one for you as well, Stefan.
Well, yeah, it is possible to recycle, but Andreas can answer this question better than me. But Constantia is working already with partner to partner up and to see what we can do for the future.
And then we had a question which is probably for Sergio. What is the standard carbon footprint per ton?
Right.
Yeah.
Yeah, I think we cannot really speak about standards. There's no standard. Although in this exercise that brought us to creating the Alpha family, we took a reference. So, and the reference being the primary footprint. So the footprint for primary products in Europe, which is around 8.5. So if you consider that footprint for the material at its very beginning, before transforming it and getting to the final product, which is delivered to the gate of our customers, this is already, we are comparing the 8.5, which lies at the very beginning, with the 4 or even the 2, which is delivered to the gate of our customers. We have created with that in mind, focusing on what we deliver at our customers' gate, and this is already less than half of what's in people's mind, which is 10.5 pertaining to primary.
Thank you, Sergio. And another question maybe for you. Will there be a net zero aluminium version available in the future?
Oh, I'd like to have the crystal ball, I must say, but I think there are a number of initiatives ongoing at AMAG, of course, at the rolling mill as such, but also at the wider spectrum in each countries. There are like regulamentations being deployed. I don't see this happening on the short term. Of course, I like to think that basically everything is possible, but I don't see the point in time when this will be available. So, yeah.
Thank you. And somebody else is asking, is Alpha Star already available?
Yes, we do have we announced the launch of this product at the end of Q1 this year, beginning of Q2. We have had great resonance from a variety of industries / applications, and both product families, Alpha and Alpha Star, are already available. Pending feasibility. So the way it works, we have to, as a mill, we have to assess that beforehand through what we call a feasibility. It's an internal one when we dialogue with the customer pretty intensely or what's expected, because in the end, you may remember I said this product comes with a certificate, so we must be able to keep the promise that we made. So it is available, subject feasibility.
Great, thank you, Sergio. And another question for you. We had, is it possible for Mr. Bottignoni to explain a little more about the current and future development of converting costs, especially the estimation of the future developments would be very interesting to us.
I'm again also on this one. I'm not sure I captured the real meaning of the question, what the conversion costs mean. If it comes to cost itself, of course I cannot comment that one. But I mean, every product requires a specific production route, and this one for packaging as well. We might even have a different production route for different customers with very similar products. So I'm not really sure what the person who asked the question meant with that, but this is the furthest I would go.
They can maybe clarify by email as well if they
Okay.
if they want a bit more clarification. Okay, now we have a couple of questions for Andreas as well. Somebody's asking, what happens to the substrate when the aluminium is recovered?
What happens to the what?
The substrate when the aluminium is recovered.
What do you mean with substrate?
That is a good question. Maybe the person can also clarify by
If they mean like the contamination now, whether it's the plastic, whether it's the paper, whether it's the food, this goes into a synthetic gas. Because we operate at 500 degrees Celsius, this goes into the gas form, which then gets thermally treated afterwards. And currently we produce electricity, and yeah.
Great. And somebody else is asking how big a percentage of aluminium does flexible packaging need to contain to be collected and to be recycled at pre-zero?
Yeah, it's economically we can do all, but economically as an average we do the 30%. So if it's packaging with just 5 or 10%, we don't do production waste, for example, with 5 to 10%, but we take pharmaceutical blisters, we take materials with 5 to 10% and take other materials like aerosol cans in a mixture, and therefore we come onto the average of 30 to 35% aluminium content in one bale. So that's why our average in the bale is between 20 and 90% aluminum content.
Great, thank you very much, Andreas. Just looking through the questions because there is a lot, which is great. Oh yes, some question for Stefan perhaps. Somebody's asking, is it possible to have PCR content in film applications?
In film?
In film, yes.
Post-consumer at the moment. For film, well, I cannot comment on that. Talking about fall at the moment, film, I don't know.
Okay. Somebody else wants to know, is there a limitation on how many times aluminium can be recycled, or is it unlimited with the use of pyrolysis? Maybe for you as well, Stefan.
Elizabeth, can you say one more time?
Is there a limitation on how many times aluminium can be recycled, or
How
is
many
it
times? Infinitely, over and over again. If we use the right technology and if we sort the alloy, so it can be infinitely recyclable.
And very important, collection. Collection is very important. You can only sort and recycle stuff that gets collected.
Correct.
Yeah, that's a very important point, definitely. Somebody's referring to the cans, and somebody's asking, have these PCR cans got 100% PCR aluminium, or is it just a fraction?
The cans that we produce with our partner has a fraction. Currently, we have 60% of real PCR, and by the end of 2023, we're working on 75%.
Thank you. Let's see what else we have. Somebody's asking, how does the printing or branding on aluminium, or particularly aluminium foil, compare to printing on paper, plastic, and other common packaging materials?
Well, it's brilliant. It looks very nice. We have a very smooth surface, so it looks very nice in the supermarket shelf. So brilliant. But on other materials, you can print very nicely as well. But compared to paper, it's a huge difference.
And in connection to that, somebody's asking, is there a preferred printing method for aluminium, for example, flexogravure? Always like gravure or offsets. Any of these best, or?
Well, no. So we can do it all. We can do UV flexo, rhodo, conventional flexo. Everything looks nice, but conventional rhodo is, of course, still, to me, the best quality.
Great, thank you. Somebody's asking, Andreas, do you also recycle aluminium plastic or aluminium paper laminates?
Yes. The adhesive, whether it's plastic, paper, or rubber, is no issue for the thermal plant.
Okay, we have a question for Stefan here, I can see. Please, can you give an example of the types of product that would be suitable for flexible aluminium monomaterials?
Chocolate, chewing gum, die cutlets, anything.
Cool, great. Another question for Andreas we have. What about recycling aluminium from flexible packaging with a content of less than 20% of aluminium? Would that work? Would that be possible?
Yeah, as I said, not as a mono input, but in a mixture. In one of our bales, we have material with 10%, 5% aluminum yield, and up to 40%, 50% aluminum content. Because important is that our pyrolysis, we are not a thermal incineration plant. We operate and are economically because we recover aluminum.
Great, thank you. Somebody is asking, is there any food contact recycled aluminium or recycled aluminium in general that can be used for packaging in the food industry? So yeah, basically, is recycled aluminium suitable for the food industry?
Is it to me, I guess?
Yes, I think that would be a good.
Yes, it is possible.
Because aluminum melts at 650. It starts at 650 degrees melting point. Aluminum doesn't have the same issues or problems that plastic has. As I think that's where the question goes into.
Well, we use recycled content in certain alloys already, so it is absolutely possible. But it's a great question, yeah.
Okay, somebody has a question to sort of dive a bit deeper into the AMAG Alforever, and they're asking, does this take into account the recycled content as well?
Yes, of course. The recycled content is, of course, part of the equation. So if you put a few things into the equation, how to get to our focal point being the CO2 content of the product, the recycled content is definitely being taken into account. Yeah.
Great, thank you. All right, let's see. I don't want to ask any questions twice, so I'm sort of having a closer look. Somebody's asking, is the Alforever Star with less than 2 tons of CO2 also possible for the Al Group 1XXX as well?
Yeah, for the 1000 family, of course, it's not easy, but potentially, yes. That was my very last slide of the deck. Potentially available on any alloy family, and this is part of the reason why it has to go through a feasibility with us, because we have to confirm. So potentially, yes, pending feasibility.
Great, thank you very much. And somebody's asking a question for Andreas, I think. Can Pyral comment on the remedying yield of the materials they produce?
I think the question is the melting yield, and the melting yield for our clean products after the pyrolysis lie between 88% and 92%.
Great, thank you.
I like the amount of questions, Elizabeth.
Yes, it's. I can say this is probably the record. I think is if it's not the record, then it's a close second. But yes, I think, especially also because we had quite a lot of time for questions. But yeah, they're still flooding in. So
Great.
yes, obviously there's a lot of interest there, which is obviously fantastic, and yeah, it looks like a lot of people have stayed on for the Q&A as well. So yeah, fantastic. Yes. Another question for Andreas is, what is the minimum thickness that can be recycled effectively?
I don't know what the question is with effectively, but all type of aluminum foil that is not steamed on. So like chip bags, we cannot recycle the aluminum. So any thickness greater than that, we can recover through the pyrolysis.
So anything that is not metallized, you mean, Andreas, right?
Metallized, yes. There you go. Yeah. Thank you, Stefan.
You're welcome.
Yes, we have a question for Constantia and Stefan, actually. Sort of quotation marks, from multi to monomaterials. Is it possible to have some success stories or examples of that?
Yes. Unfortunately, I'm not allowed to mention the names of the customers, but we have lots of success stories, especially in the chocolate wrapper area. So we used to use, like we were showing early in the presentation, aluminum paper specification. Now we are going to eco alulam, but unfortunately, I'm not allowed to talk about the customer names. But you will see it shortly, maybe now already at this point of time in the supermarket shelves.
Great, thank you.
You're welcome.
We have another question for Andreas, which is quite detailed, but I'll read it out anyway. Obviously, our audience is also well versed in the subject. How would you, in general, evaluate the sustainability comparing a multi-layer film, aluminium plus and plastic like PET, with an aluminium vaporized film out of PET? According to today's presentation, it sounds like the multi-layer film with higher amount of aluminium is the more sustainable option, although if we avoid the higher usage of aluminium in the vaporized film.
I can only comment on the aluminum industry. I have too little experience with PET or other types of plastics. So, as I said, the advantage of aluminum is that it's or as Stefan had said, the advantage of aluminum is that it's infinitely recyclable, as long as it always gets collected. And regarding the sustainability, because it's infinitely recyclable, I can therefore say the conclusion is that it has a high sustainability record. To take also into consideration the next question regarding PVC, it's chlorine. Even our plant, we take it. For example, the pharmaceutical blisters have the PVC on it as well. We take it as a byproduct within the mixture, but we don't do solely blisters, because any thermal plant always has problems with chlorine.
Great, thank you very much, Andreas. So, yeah, I think it's probably time to wrap up the questions now. Obviously, if we didn't get to your question, then you have the email address right there to get in touch with the team and get your questions answered. So, yeah, that just leaves me to thank everybody for joining us, and also thank our speakers, Stefan Lampe, Sergio Bottignoni, and Andreas Reisner. Do you have any final thoughts you'd like to leave with our audience today?
Well, I would like to thank the audience for dialing in. I've seen a number that is huge, so I did not expect that high number. So thank you very much for dialing in to today's aluminum webinar. So it was a pleasure and was very exciting. So I enjoyed it very much. Thank you also, Elizabeth, for being our host. Thank you.
Same for me as well.
And same for me. Thank you, the audience. Thank you for the questions. And as you have seen today, I think we can say loud, the future has already arrived. So don't hesitate to ask, and we take it from there. Thank you very much.
Thank you.
Great, thank you very much, everybody. Just to let you know, this webinar will be available on demand within the next couple of days, and you'll be sent a link to access it in case you want to recap on anything you've seen in today's session. Thank you very much.